Right. So we spoke about terms quite a lot, and these are generated when Elasticsearch analyzes strings. So by default, when you send a string field to Elasticsearch, it will take it and it will break it down in what is called a tokenizer. So from the whole string, it will break it into words, so to speak, and then it will take that stream of tokens and it would run them through a token filter. And this is what basically the standard analyzer, the one that's used by default, does. So if you send a string like this, then first it will break down, it will get rid of all these characters like parentheses and so on. So you get the words, and then it applies the lowercase token filter, which does the lowercasing. So whenever you search, because at query time, most queries are also analyzed. So when you search, whatever you're searching, for example, with uppercase or lowercase, the actual terms being matched are all lowercase, so you will get the expected results. Now, when it comes to aggregations, which Rafal just showed, these are like the terms aggregation, for example. These will count the actual terms, not the complete values of the fields. So it makes sense to run aggregations on fields that aren't analyzed, because you don't, for example, if you have a city name, okay, and you have New York, and you run a terms aggregation and that field is analyzed, you will get separate counters for New and York, and that doesn't make sense. So what you want in this case is not to analyze that field and have New York as a single counter. But the thing is, when you run aggregations, that this sort of inverted index structure isn't appropriate, because let's assume we have this very small thing, and we run a query, and that matches two documents, 2 and 3. Okay, so now if I want to get the counters of how many times each term came up in those matching documents, then I would just have to run through all the term dictionary, and that is not efficient. So what we need instead is a columnar data structure, like you have in other data stores. And on analyzed fields, the only option is to use what it's called field data. So basically, Elasticsearch takes the inverted index for that particular field where you're running the aggregation and uninverts it into this columnar structure. And then it's easy to just say, to just pick the matching documents and count how many times each term appears and return you the results. The problem with field data, there are actually two problems with it. One is that doing this uninversion is expensive. You typically do this the first time you do an aggregation on a certain field. So that means it has to take all the documents that have that field, and it could be billions, and build this structure. And that structure would be in memory. So obviously you could run out of memory, or just the query will fail because Elasticsearch will kind of detect. There's something called a circuit breaker, which will try to estimate how much memory a request will use, and if that's too much, it will just fail the request. So normally when you do aggregation, you would do that on not analyzed fields, and on not analyzed fields, you have an alternative, which is called doc values. And with Elasticsearch 2.0, which is right around the corner, this is the default for not analyzed fields. So basically, we'll build a structure like field data, a columnar structure, but it will build it when you index the documents in the first place, and that will be stored on disk next to your inverted index. So that means you don't bother your heap with that. You don't have to do any uninverted thing for your first query. And then the operating system can be smart and just pull out bits of your index as it needs them and keep them in the operating system caches. So this is much more efficient than field data for pretty much all use cases, certainly for logs.